All right, so we are going to be doing some T-charts today. And so T-chart is a strategy that helps you break down the atoms and elements that are in a compounder formula. So I've got 3 different examples here for you today. We've got baking soda, hydrogen sulfide, and zinc. And so we are going to do elements and atoms and T-charts for all of those. So let's get started. All right, so the first thing you do, you just take a look at your formula and see what we're working with here. And so we have some elements. We need to count them. One trick I do is I count the capital letters. The capital letters tell me how many elements we have. So I've got a capital N, I got a capital H, I got a capital C and O. So the capital N and little a is sodium, and then we have H, and we have C, and we have O, for a total of 4 elements. Okay, so let's start counting. Remember, there's no coefficient, so if there's no number here, we assume 1. We have 1 Na, we have 1 H, we have 1 C, and we have 3 O's, for a total of 6 atoms in this molecule, and in this case compound as well. So that one's done. Let's move on to hydrogen sulfide. Right here we have 4 as our coefficient, so that changes some things. We get to do a little math here, which is going to be fun. So we have H and we have S for a total of 2 elements. Now we have to hippity-hoppity distribute that property. So we got 4 times 2, which is 8 hydrogen, and 4 times 1 is going to be 4 sulfur, for a total of 12 atoms here. There's a trick that you can also do as well. If you're not 100% sure and you just want to be clear and make no mistakes, you can always just put 1s. If you wish. Like here, you could do a little 1 there, if you wanted. So we know that we have 8 hydrogen atoms, we have 4 sulfur atoms, total of 2 elements, total of 8 atoms. Before we jump into the last one of the reasons why I love to do T-chart for every single question I ever get in science is because you pretty much have all your answers here. The science star question may say, how many total oxygen atoms are there in 2 molecules of baking soda? So as you can see, that would change some things. They only have 1 written here, but in the word question, maybe they have 2 in the formula. So what you can do here is you can multiply all of this by 2, and that would give you 2, 2, 2, and 6, for a total of 12 in this case, if there happened to be a 2 there. Anyway, just a little bit more if you run into that scenario. Let's do the last one now. We have zinc. And I'm going to go ahead and slide it over, just like so. Okay, zinc. So elements, we have Zn, we have N, and we have O. So we have 3 Zns here. We have, well, let's really look at this. We have 1 N, okay, times 2 will give me 2 N's, times 3 give me 6. So let's do the O's. We have 3 O's times 2 will give me 6, times 3 will give me 18. So 18, 24, 25, 26, 27, and 3. So once again, that is how you would break down a formula that actually had a parentheses in here. And so always remember that if you have a subscript attached to the parentheses, that subscript goes to each element within the parentheses. So in this case, let's go inside the parentheses first and know that we have one N and three O's. This needs to be multiplied by that 2. So 3 times 2, 2 times 1. Then you take those results and then we make sure that we distribute the property after the fact. So we have to do what's in the parentheses first, know how many atoms we have, and then multiply it all by the 3. And that's how you get 3 total elements and 27 total atoms when you have 3 molecules of zinc. All right, guys, that's it. That's how you do T-charts. Good luck on your practice.